Hello everyone. Hello. Hopefully things are going okay. Let me see. I don't know what's going on with my window here with the big monitor. Let's see. All right. Here we go. How are you guys doing? Let me get my restream chat up. Here we go. We got that going. Hey, hello, One Clown Shoe. How are you doing today? So what we are talking about today is life outside of Earth. How exciting is this? Hey, Andy. I'm going to be hanging out with Andy next weekend for our Spirited Science show. So that's pretty exciting. Woohoo! So, I'm going to just double check I'm live everywhere. I always do that on here. Make certain sound is working fine. I think sound is working. Hey, Michael. Hello, everybody. So, I have pretty exciting news. I had said so on the 24/7 stream. Yep, we're on Periscope. Hello, Periscope. I guess we're going to be on. I'm also streaming to Facebook. Make certain I'm on there. Hello. Will he shock you? Noah, yes. I'm live on Facebook, and I can see I'm on YouTube. Pretty certain I'm on Twitch. I'm going to hop over there and have a look. I'm so excited to tell you guys that you guys did it. You guys did it. So I've gotten I'm now being under review for YouTube for monetization. So thank you guys so much for that. I'm so excited, and so you guys made that possible. All y'all came together and you were just like, let's get her those hours. And so you guys managed to get me like an extra 600 hours or 600 to 700 hours in less than a week. So yay! Thank you for that. Yay. Thank you so much, guys. Thank you. Thank you. Yay. So I'm really excited. So today, the topic that won the poll last was life outside of Earth. And so life outside of Earth is the topic what we're going to talk about and how that's possible. We're also going to touch a little bit on the Mars mission. So let's go ahead and get started. Woohoo! All right. Yay! How are you guys doing? So that was my really cool intro from Gonna Go For It, also known as Peter. He makes all of my really cool intros and stuff, so I always give him a little bit of a shout out for that. So we're going to talk about life in space a little bit. We're going to talk about the things like astrobiology, where we can find life, what we need in order to have there be life, where that research is going, what it is that exactly that astrobiologists study, and is a Mars mission really possible? So let's break down a little bit about astrobiology. It's essentially looks at the study of life outside of Earth. It looks to the chemistry associated with life and what we call biosignatures. They study extremophiles for comparison to kind of see what it'd be like on other planets for this sort of thing. And they also look at ancient types of rock. So ancient rock that we have on here on Earth. And so there's our chat. Boom, right over there. Xenomorphs, wouldn't that be something? I do have a bit of a beef with Prometheus. You guys saw that terrible film, Prometheus. And then I think I tried to watch that other alien film, and it was just really awful. Hello, Andrew. Hey, Nim. Yes, your money is on low, Michael. Oh, goodness. If we do find life out there, we will most likely be offended by it. Probably because it can withstand things that we can't. Wouldn't that be funny? Because that's pretty much what they look at. So astrobiology, that's a pretty hard field to get, to do. Hey, Hemphill. Prometheus didn't happen. Shush. That's the film that I like to call the worst scientists ever. They break so many basic rules. And anybody that's had any kind of lab at all, high school or otherwise, would probably understand that they just break all kinds of safety rules. Just being on the frickin' like, why would you take your helmet off? So goodness. No, Iowa, the moon of Jupiter. Didn't you read 2001? Oh, goodness. So, what is astrobiology? All right, so this is essentially what it breaks down to, and what we're going to talk about a bit about. It focuses on organisms that live in the harshest conditions of Earth. So Penn State, I just happened to come across their website. They work in coordination with NASA. They have an astrobiology research center to develop novel and effective approaches at detecting and characterizing life outside of Earth through investigating ancient rock that reflect the rock we find outside of Earth and on other planets and comets, that sort of thing. So they study these tiny ecosystems looking for biosignatures that can mirror the conditions that we would find life outside of Earth. So where exactly do they look? So what does this mean? Oh, goodness. So what does this mean, essentially? I'm trying to, check a few things. I have people sending me messages and stuff. All right, so what does that look like? So essentially, this is what they look for. They look at ancient rocks to try to see what those tiny ecosystems are like. They also look at relevant microbial ecosystems, and they also look for various different extraterrestrial type of settings. So what does that mean? That's essentially what I do here. I talk about what things mean. All right. So biosignatures, that's what they're looking for. These extraterrestrial type of settings. It's something called biosignatures. Sounds like this ties to spectroscopy a little bit. And they are also looking at, they do look for things like the different types of molecules. They look for new biosignatures. So one biosignature would be like DNA. So they look at different types of molecules to see if they form into specific patterns. We have very organized different structures in living systems. You have the formation of proteins. You have which are different little amino acids that are kind of like linking together. And so these presence of these biomolecules and these presence of these organic compounds are also what they would look for in a biosignature. So the actual molecules themselves are something that they look for. Now they look at ancient rocks. And so one clue for astrobiologists is they look at Archean and Proterozoic eons. That's those particular, they offer the best opportunity to look at the microbial world. And so they're hoping that they were looking at the ancient record on Earth to kind of see a generalized idea of early Earth, these geochemical signatures that are kind of produced by these different types of teeny tiny little microbes. And they're preserved in this ancient rock so they can kind of categorize it over time. All right. So another thing they do, they look at the different type of relevant microbial systems. You have a spectrometer there, but it's for water spectroscopy. Water spectroscopy is pretty cool. like Oumuamua. Is that how you say that? Is that Oumuamua or is it Oumuamua? So that particular group at Penn State, they look at microbial life in the different type of mission-relevant ecosystems. So they dig down into the Dead Sea. They look at the Chesapeake impact structure. They also look at the methane seeps of the Eel River Basin, and they also look at Greenland glacier ice. So they look at these extremophile type of ecosystems where you would find organisms living in the harshest types of climate. They also look at the abundance of sulfur gases. So they would take into consideration the the different atmospheres associated to conditions outside of Earth, which would be like abundance of sulfur gases. They would elucidate how those particular gases would be expected to evolve on younger terrestrial planets. They also look at planet formation and the presence of migration and model radial transports of volatiles and young planetary systems. Their website uses all kinds of really fancy sciencey stuff, but the thing is what they're essentially looking for is how these planets form, what these early atmospheres are like, and then they also look at and see on our own Earth those types of atmospheres and those types of conditions to study life that can survive in those situations. Hello, Cheris. Hello, Andrew. Hello, Henry over on Periscope. So, oh goodness, people sending me messages. You guys rock. We have found rocks form Mars on Earth, and we have found microorganisms that could survive on those rocks. Yeah, we have. Andrew's a computer scientist and engineer. Hello, Nether6. So it's pretty interesting. That's right. Panspermia, how fun. Well, I'm looking mostly at how it is that we go about the search of life, what things need to be tweaked in order for us to find the search for life. So it's kind of neat. We're kind of touching on a bit of that today. So what kind of life would we primarily find? So you notice I had a tardigrade up before. We would think that cellular life, like simple-celled organisms, would be most feasible. But tardigrades, they're freaking amazing, and they give us clues as to what kind of life would survive outside of our own planet. And tardigrades are freaking amazing. If you're not familiar with those particular organisms, we've been studying them for a long time now. And the thing that's really, really cool about tardigrades is quite a few things. They're around 0.05 millimeters, and they can get as large as 1.2 millimeters. Now, if you're not on the metric system, you should totally get on the metric system, because I don't know what to tell you. Frickin' metric rules, and that's pretty much what we all use on outside of the U.S. I don't know why we haven't gone metric here. Yes, my puppy. Frodo is my rescue pup. He is learning how to properly be dog in the house. You know, we don't put him outside. He stays in the house with us. And so, Andy, I think you gave me like advice to crate train the puppy. He actually likes his little crate. It's like a medium to large size. So, there you go. Oh goodness. Can you imagine trying to make a pet vest and Santa hat for one though? Oh my goodness. So back to like the SI units. Are they always tardy for school? Tardigrades are like wizards. They arrive exactly when they mean to. Yes, Imperial crashes you into Mars. It really does. Yes, Iceland is one of the more popular places for astrobiological research. Yes, it is. Iceland is, and that's primarily for a particular extremophile that lives there, and we're going to talk about the different types of extremophiles. So the things about tardigrades is they can live pretty much anywhere. They can live in extreme heat, they can survive cosmic radiation, they can live without water for 10 years, they can be frozen and brought back to life. A recent paper that was published, I believe, in Cell Biology was the fact that they took frozen tardigrades that had been frozen for 30 years. They formed this thing called a tun, T-U-N, around them. It might be a tune or a ton. I'm not certain the pronunciation. But they formed this thing around them that preserves them. And it's like this little bag that they put around themselves. And so they can be frozen and they can be thawed and brought back to life. They're over approximately 600 million years old. They reproduce both sexually and asexually. So not only can they mix up their genes with a little bit of sexual reproduction, but they can also reproduce asexually. There are a whole lot of subspecies of tardigrades. So essentially, when you break it down, the tardigrade phylum branches out into 3 classes, 5 orders, 20 families, 15 subfamilies, 105 genera, 4 subgenera, 1,018 different species, and 67 subspecies. So tardigrades are very, 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 very diverse, and they persist in survival. Guess I could put it in the freezer if I had to go on a trip. Yes, you could probably. And you know what? Your tardigrades would probably still just be fine. For every one of us, there's a billion of them. I wonder how they prevent the water from crystallizing, because that's what usually causes a cell to get destroyed. They put like this thing called a TUN. It's a ton around them, and that like kind of houses them to where they'd be okay. It is the original sea monkey. Icelandic volcano names are great if you want unpronounceable names. Oh my goodness. Yeah, you would have to make a lot of Santa hats on teeny tiny ones. They usually don't get larger than about a millimeter, which is 1/1000th of a meter. So if a meter is about 3 feet, 1/1000th of that is about a stand. You know, they don't get bigger than about that size. So they're pretty tiny, and, you know, they pretty much just suck on algae and lichens and stuff like that. We don't need much to survive. So tardigrades are really good models on helping us understand, and they're considered an animal. They're not considered a microbe. They're actually considered an animal. Where do tardigrades fall on the phylogenetic tree? Well, they are considered animals. I could pull up their actual... I could pull up all the information on that, but there are a lot of them and lots of different species. But they're a multicellular organism. So it's pretty cool about that with the tardigrades. I didn't actually pull up all of their stuff, but other extremophiles. So the list of all the different kinds of extremophiles, if my computer will catch up. All right. So the other extremophiles that scientists look at, well, there's the acetophile. Phile means loving. Phile means they just love it. They are early in the Metazoan clade. Thank you for that. All right. So acetophile means they love acid, and they like acidic, low pH values. Then you have the alkaphile. They like alkaline situations where you have the high pH values. You have the anaerobe that can persist and grow in the absence of oxygen. Hello, Christy. Oh, my goodness. And you have the facultative anaerobic. In those particular ones, they're organisms that grow in the presence or absence of oxygen. So you have ones that actually can be with oxygen and without oxygen. You have the obligate anaerobe, and that particular one can grow in the presence of oxygen. And the presence of oxygen either inhibits growth or kills the organism. Cyanobacteria from the Lake Leduc Spring, they're found in Yellowstone. They're an example of that. You have endoliths. Endoliths are organisms that live inside rock or in the pores of mineral grains. So you can find these endoliths. Endoliths are pretty cool. Halophiles. They're organisms that require high concentrations of salt for growth. So things from our halogen group for all the chemistry people out there. Halogens, fluorine, chlorine, bromine, iodine. So those sorts of things. An obligate anaerobe. Yes. Isn't that funny? That should be somebody's Halloween costume one year. We should all dress as extremophiles for Halloween one year and then guess what each other are. I am an obligate anaerobe. How funny would that be? Methanogen. A methanogen, guess what they like? They produce organisms. They produce methane. So they're an organism that produces methane. And so essentially that comes from a reaction of hydrogen and carbon dioxide. And they tend to be members of the archaea group. Just no F orbitals. I hate F orbitals. Y'all, freaking Andy judges me on that. I don't like F orbitals. They scare me. So Rob's going to be cyanobacteria for Halloween. They look good in blue. All right, all right. Okay. Oligotrophs. Guess what oligotrophs are? Troph usually means eating something. So it's an organism that grows best in nutrient-limited conditions. So if there's not a lot of nutrients around, they do just fine. Then we have the piezophile, or the barophile. Guess what they like? Guess what the piezophiles like? Do you guys know? They like high hydrostatic pressure. If you guessed that, then you got it right. A psychrophile. They have optimal growth at temperatures that are 15 degrees Celsius or lower. So they're the ones that really, really like the cold, the freezing cold. Thermophiles. They like to turn it up. They like the heat. We might have some thermophiles in our chat. I believe Andy is a psychrophile because he likes the cold temperatures. That's what he tells me. Thermophiles like the heat. Hyperthermophiles. Now, thermophiles like 40 degrees Celsius or higher, but hyperthermophiles, they like it super, super freaking hot, 80 degrees Celsius or higher. Then you have the toxitolerants. Toxitolerants are able to withstand high levels of damaging elements. So pools of benzene, nuclear waste, that sort of thing. And then you have the xerophiles, organisms that are capable of growth at very, very, very low water activity. So, is it F orbitals or F orbitals? I should have stayed in Australia. Isn't that everything that can kill you lives in Australia? But that's how it is. So let's look at different types of extremophiles other than tardigrades. So what kind of things would we be looking at? So let me get y'all to the right screen. Here we go. Brine shrimp. They are saltwater survivors. Isn't this our, what was it? Oh, somebody said the word before. You guys. Somebody called me out. Andrew called me out. I'm in a leopard print. Yes, I'm in. It's kind of like a onesie, but it's really cold here. I try to get away making people think it's a hoodie. But yes, I am in a onesie, and don't judge me. It's cold. Sea monkeys. There you go. Thank you, alias, fake name. Sea monkeys. Brine shrimp. Saltwater survivors. That's not what this picture is over here, though. Anybody can guess what this picture is? It's one of the things listed below. It's like, they're kind of creepy, gross looking. And if you look at their faces, like, really close up, you know, there you go. It's just, they look like some kind of monster from an old monster film. This picture right here is the methane ice worms. They're ice dwellers. They're found in glacial caps, and they have their entire life cycle is at these freezing conditions, which makes them particularly interesting, especially to astrobiologists in very, very cold conditions. Rushing fireball microbes. They are currently, scientists are tweaking their DNA to see if they can turn them into carbon dioxide eaters. And so if that's at all possible, that might help with our current conditions, especially with the CO2 levels bumping up a bit, you know. And then you have the Lazarus microbe. They are radiation resistant. And so those particular ones, people like scientists are tweaking with to see what it is that they can do with these particular radiation resistant microbes, and maybe they can apply that to radiation treatment. I believe that those are the microbes that they're playing with mice as a possibility to deal with, make mice radiation resistant. Might be a good thing, especially for people that work around it. So those are various extremophiles that they're looking at for these types of organisms. Ah, where'd you guys go? There you are. Boom. Oh goodness, the thing is if you think everything in Australia is out to get you, you'd die of starvation because you'd never leave the house. Well, you know what? To be quite fair, I think it was like the Wild West had similar things when they were settling out west. You know, you got some things, but it's quite different because Australia is an island in itself. So you also have the ocean stuff to contend with. Oh, you think it's awesome? I'm comfortable wearing whatever I want on camera. You know, that's just... I think it makes it interesting, too. I used to try to wear sometimes I wear different nerd shirts and stuff. So I do kind of wear whatever I want to on camera. I think, it's fun. You should have fun and do what you want. And honestly, this is Saturday morning for me. So we have Saturday morning science. You know, we don't have Saturday morning cartoons anymore. And if I was the host of a cartoon show, I'd probably wear my jammies too, and you'd see me sitting here eating a bowl of cereal, watching cartoons with you. So this is Saturday morning science. So if you're out and about in the morning, you know what? Hop aboard, wear your jammies with me, and we'll talk science together. So what would be the waste product? You know, that would be pretty interesting. So if they were like photosynthetic, you know, plants actually they take in CO2 and they make sugar from that. So the waste product might very well be oxygen and water, you know, that could be a thing. You tend to be boringly business casual. Generally O2, yes. All right. So these particular, let's talk a bit more about organisms, these extremophiles. All right, so the more we study organisms who live in extreme conditions, the better we can understand how organisms could live outside the safety net of our planet. There are limits to astrobiology. Now, this is something that's pretty cool. The National Academies of Sciences, Engineering, and Medicine are publishing a strategy for finding life outside of our planet. It's still under editorial review, but you can actually read the entire strategy for yourself, all 186 pages of it, as experts compiled a list of things that need to be done in order to refine our search for life. And so what I can do is I can actually post that for you. I'll put it in the link. I put it in the description for this particular episode. I'll have to update it because it's something weird with Restream. I'm not able to fix the descriptions until after it posts. But you can also go to my website, ScientistMel.com, and I'll post all of my slides from this particular talk, and it'll have one on there listed with the different sources that I use for this discussion that we're having. And you can click on it and check out all 186 pages of where they will move forward with astrobiology. So I'll break it down a little bit for you. I still have $5 riding on there being microbes on Jupiter's moon Europa, or even Titan. I'm going to talk a little bit about Titan here in just a bit. You're currently writing a paper on science-related conspiracy theories. It's kind of scary how poorly physics and other areas are currently taught. Yes, it kind of is. And I think a lot of that has to do having been an educator in U.S., science educator in the U.S., not a lot of focus is on, there's so much focus on standardized testing and not so much on how to think. So I think a lot of school districts are pushing more towards teaching how to think how to find relevant sources and boosting that across the board. There really needs to be more cross-curriculum. We need to not only teach how to read, but we also need to teach on how to read science, because that's pretty difficult. Some people don't understand that. You look at like the ACT and the SAT, a lot of the science stuff there is they discuss what essentially everything you need to know is usually in that little paragraph where you can analyze it and answer the questions, but that's not taught a lot. So yeah, it's pretty scary about education in regard to that. So let's talk about the breakdown a little bit on what is in this 186-page document on what we need to do for life. Here we go. And I'm covering up part of it, so, well, no, not so bad. All right, so essentially, what this particular document says is that NASA needs to collaborate more with private organizations in other countries in order to kind of come together and move forward in astrobiology. That's going to be essential. The focus needs to be on subsurface life, because we know atmospheres can play a role in whether or not life is possible. Subsurface life is extremely important, especially since the more we find out about extremophiles on our planets, that they're living right under the surface, that the atmosphere doesn't play so much as a role, so much as what those subsurface conditions are. More extremophile research. This is helping us understand a bit better that, one particular organism may not do so great, or lots of organisms may not do so great in one condition, but another organism just thrives in it. So that gives us more insight as to how these biological processes work. We need to refine biosignature research. So just because we have particular conditions within Earth on this particular thing. Okay, we have DNA, we have all of these other things here, we have indications of methane on another planet. Well, that's a byproduct of some organisms that live on our Earth. That doesn't necessarily mean life is there. So we need to refine this biosignature research in that we can vet and filter out what actually is viable proof to show that there could be life on another planet, as opposed to something that may look like it is, but it's really not. And also, we need to have more funding in the SETI project. SETI wasn't considered a part of astrobiology, but the fact is if we're getting radio signals, that's a form of communication from different types of biological system, different types of biological things. We now have radio waves coming at us from a distant galaxy. I think it was over 1 billion light years away. This is still important information that we need to find and investigate. So we need to have more funding and bring SETI to the forefront. And this particular document talks about that, and that it's really, 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 really important. So Titan. How exciting is Titan? And so, yes, the Europa Clipper mission should be really, really good. It is a good candidate for life. Titan and Europa both. So I'm going to discuss a little bit about Titan, but you can check out more on Europa in the mission associated with that. So the moons of Saturn, they have loads of organic molecules, lots of methane, and scientists are studying Titan as a possibility of extremophile presence. So that's something that we can check out. Could extremophiles theoretically be larger than tardigrade size, or a small size kind of required for survival? When you're dealing with harsh conditions, the smaller, probably the better, because that's less opportunities for things to kind of get messed up. You know what I mean? Humans are inherently complex organisms. We are very complex. And so the more complexity, the more things that you have, the intricate things that could go wrong within us. For that, we require much more energy than a tardigrade because we're larger. We also require more resources than a tardigrade because we are much larger. So size tends to be a pretty important thing. Well, thanks for hopping on here, Kerr. But it did, I would think a microbe, like a single-celled organism, or a small animal like a tardigrade because they have persisted over millions and millions and millions and millions of years. They're still there, and they'll be here long after we're gone. Oh, no problem. No problem, Karis. So the smaller is probably the better because they're going to be more efficient. So that's just kind of how it goes. Yes. So Nether, thank you for responding to that question as well. High pressure environments put a huge limit on size. Yes. While toxic substances do less so. Yes. Complexity of organism is going to play a role as well. All right. What about something like cold-blooded organisms that require less energy for survival? Yeah, that's true as well. We could. All right. So Nether's theorem. NASA is currently trying to decide amongst 4 proposals for the next major space telescope after James Webb. Extrasolar life would be kind of cool. Might it be kind of like that? Well, it depends also on the type of environment. We have all kinds of different extremophiles, and they can do different things, and it's just not one particular characteristic. Those characteristics can overlap. And so it's kind of like where if you're looking at, like with Titan, let me talk a bit about that, and then maybe that'll help. So when we're talking about what requirements would need to be, all right, so why would they be looking at Titan or Europa, for example? Well, there's a large amount of organic molecules we see actively in living organisms within our own planet. Now, it also has a large amount of methane, which is a byproduct of organisms on our own planet, and it can also be used as a fuel source. So scientists are intrigued by Titan and Europa, and that formation of complex organic molecules have occurred in lab within similar conditions as the Titan atmosphere. Now, the atmosphere resembles that of early Earth, which also gives a nudge towards life on Titan. Now, of course, more research needs to be performed in order to vet and validate such biosignatures, and more information would need to be collected, especially at the subsurface levels of Titan that presents its own challenges. A land rover would have to survive the current conditions that are at negative 179 degrees Celsius. Well, let's see. Cold-blooded isn't that much more energy efficient, but there are alternative metabolisms being compared in xenobiology. Yes, so far nothing beats carbon-based oxygen breathers for energy. That's true. That is true. So thank you guys for answering Karis's question. So what do you guys think about the Mars 1 mission? There's actually a timeline for the Mars mission. Extrasolar planets, not extrasolar life. They'll have the ability to detect biosignatures. That would be cool. So yes. So the Mars mission, they have a timeline for that. That's pretty exciting. I doubt that could even be multicellular life without being oxygen breathing. Well, I don't know. It would be interesting. It's hard to know. I mean, my coffee has gotten cold. That's okay. That's how cold it is in my house. My coffee is cold, and I topped it up before the show. Yes, there's sounds coming out from behind me. Oh my goodness. So, what do you guys think about the Mars mission? Because that's the next thing we're going to talk about. Is the Mars mission and the timeline. You can actually go on the Mars 1 website and check out what their schematics are and what their plans are and where they're at with Mars 1. So, silicon-based life, I think silicon-based life is considered possible. It's within the same group as carbon. And it's also a semiconductor, which is kind of cool. Life finds a way. Oh, goodness. Okay, and Jamie on Periscope asks, is there a potential for sulfur-based ecosystems as at black smokers on Earth? Well, I mean, I don't see why not. See, that's the thing. we have to studying extremophiles, especially where we have like those vents and that sort of thing, that with the hot sulfur vents and stuff, that would be, to me, that would be a good indicator of whether or not life could persist on other planets, especially where you're dealing with sulfur gases. So silicon, it's in the same family as carbon, so it can make 4 bonds. Silicon bonds, they do take a lot of energy. Yeah, they do take a lot of energy put together. If something's carbon based, carbon is such a fantastic molecule for life that, it pretty much bonds with everything on the periodic table. It can form complex structures, pretty sturdy ones. The bonds are easy enough to break in order, as a good fuel source. So the things about carbon is just amazing in itself. If we're able to find those organic molecules and that sort of thing, that would be the best thing for life, using arsenic. I haven't heard about that. If carbon was a man. When I was teaching polarity, I would talk about sexy carbon, and then carbon it likes to hook up with everything on the board. It's funny. I think the Marie Curie Institute put out a video on, and if you haven't checked it out, it's hilarious. The Curie Institute put out this video on if elements were at a party and how they'd interact with one another. Carbon shows up, and just hydrogens just start coming out at the party, and they're just all like in this huggy state, which is pretty funny. Funny how life seems to be made of the most common elements. Yes, we hold all of the most abundant elements within ourselves except for helium. Helium is the only element that we don't have within us. That's found a lot of in the universe. So yeah, it wouldn't make such a good thing for a water life. You're right about that, Nether. Oh gosh, carbon does get really crazy when it adopts a free radical. Yeah, yes it does. Hello everyone. Oh goodness. So you guys want to talk about the Mars mission? This is a cool chat too, what we got going on about discussion of possibility of life. And I want to thank you guys again for helping me get under review for monetization. Now, as an aside, for like the 24/7 project I have, it seems like I got a pretty good response because people can drop in and kind of check out like a lot of the different shows that I've done without having to go through and watch all of the previous episodes. So what I may do, I'm going to go and update those episodes with more current ones as well. And I'll have them still based in the biology block, the physics block, and that sort of thing. It reminds you of field trip building nanotubes. Yes, Andy and I went to a science museum and checked out the nanotubes. We were trying to build carbon nanotubes, but unfortunately the foam blocks that they have don't really represent interatomic forces so well. So even though we had our structure perfect, it was falling apart because they weren't sticky enough. Oh goodness, isn't ammonium? Yes, ammonium is, because we find it's got nitrogen in it, which is also part of what we call amino acids. And so if they're able to take, like this Titan, for instance, which is pretty interesting, there was a team, I believe a NASA team, that was sitting there trying to replicate the atmosphere of Titan. And they saw that these complex organic structures were being formed, I believe, with acetylene and also, I believe, methane. And I think there was a little bit of ammonium involved. But they were forming these complex structures based on that, which in their own way, just started to form on their own. And so in a lot of cases, especially when you're dealing with carbon and certain types of organic molecules, they tend to form these structures under certain conditions because they tend to be more thermodynamically favorable. And so a lot of thermodynamics, even though we have the universe is going to bits through, entropy, we still manage to have these complex formations happening that tend to be more thermodynamically favorable. So if you've not checked out one interesting book that I like, especially when you're talking about biogenesis and stuff like that, Touchstone of Life by Lowenstein. I believe it's by Lowenstein. Fantastic book. I was introduced to that book in my physical chemistry class. Touchstones of Life. It talks about thermodynamics involving the origins of biomolecules, and how kind of life originates to a degree based on the chemistry of it. It talks a lot about Maxwell and Maxwell's demon and information theory, which is really, really, really cool book. So do check out Touchstone of Life by Lowenstein. Great book. S&P orbitals for the existence. When, yes, I know about those, Andy. F orbitals I hate, but I can talk all day about S&P orbitals. Sexy carbon. And in polarity, when I talk about the water molecule and why that's such a fantastic molecule for life, but the fact that it's polar, and sexy oxygen's hooking up with the hydrogens of the other molecules. Oh, goodness. Thermodynamics really seems to not only favor, but possible even demand the forming of carbon biochemistry. It's only a few jumps from that to carbon-based life. That's true. It's really, really cool. Another series that I recommend watching is The Human Universe. Human Universe by Professor Brian Cox, my favorite astrophysicist. The Human Universe is absolutely amazing, and it talks about how it is that humans, the only animals that we know of, that are able to build spacecraft and actually have left our planet in the search for life outside of Earth, and also to just learn more about the universe around us. We don't know about any other organisms on our planet, in the past that may have gone and tried to search. We have no evidence of stuff outside of us doing that. And so it talks about, he talks about how it is human development, how the development of the brain, all of the different factors that played a role in our brain size getting larger. And it's just an absolutely amazing series. And he talks a bit about the thermodynamics behind how it is that life is, how life comes together, and also Wonders of Life. If you've not seen Wonders of Life, go watch that stuff. It's great. I watch that for fun. I've binge watched Professor Brian any day. I think in his book. So I'm plugging Brian Cox's stuff. Okay, that's what I'm doing right now. E equals MC squared and why we should care. Fantastic book, talks about the history of the derivation of the energy equation, and I love his stuff because he just explains things so well. So I do like a lot of his work, especially when it comes to physics, because I had physics fear, especially on the math side. But the brain does have that hair if it's that your thing. I might be blushing. I like Professor Brian. Oh my goodness. So let's talk about the Mars mission before we get too out of hand. Let's talk about the super awesome Mars mission. And if you go and you can check out mars-1.com/mission/roadmap, and you can get an idea about what it is that they're going for. So NASA has a timeline for Mars 1. They're looking at landing in 2030 with a demo mission starting in 2022. People sending me messages. You guys are funny. So that's what they're looking at for the Mars mission, is like hopefully, be solid on the planet in 2030, but at least demo mission starting in just a few years. So this is all really, 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 really exciting. Why haven't we heard from other life forms? Which is pretty interesting. So I know people are like on my trailer for this show. They're like, don't talk about the Drake equation. If you're familiar with the Drake equation, it takes into consideration the possibilities of other planets within our galaxy holding life, and if there was life at all on these planets, we probably would have already picked up signals by now. Now, we are getting some radio signals. I haven't read that article. I saw something pop up about radio signals coming from a distant galaxy that's a billion or so light years away. The thing is if we're just now getting those radio signals, it's billions of light years away. It's not current. You know, it's not currently what's going on in that galaxy. It's a long, long time ago in a galaxy far, far away. So, you know, so some people think ferrous nucleic acid and peptide nucleic acid may have been precursors to RNA. It's really interesting. So that's why it's really important that we persist in looking at old rocks to kind of see what these types of things are there. FRBs. Oh, goodness. So how do I feel about the scientific dictatorship? Oh, is there one? Because last time I looked, I hadn't noticed that there's a What do you mean a scientific dictatorship? I'm not certain what you mean by that. Aren't the input values in the Drake equation a bit low nowadays? Probably. We have more information involved. But like with the guy who formulated the Drake equation, I'm trying to remember. I think did he pass away recently? First radio bursts. FRBs, first radio bursts. Woohoo! Billions of years ago. Billions and billions of years ago. Oh my goodness. This is all exciting stuff. But it's really weird. It's like you kind of think about if there is like a planet far away from us and we're just now getting radio signals from them, they just might be getting radio signals from us, but not really because we weren't around billions and billions of years ago. We weren't really putting out any signals like that. Furby. Wasn't that one of those annoying toys that made horrible sounds for some reason? Aldous Huxley and Bertrand Russell discussed the scientific dictatorship. Well, I have to have a look into that because I haven't heard of that. My nose has been in a book for many years now, like working on my education. So, oh, might be important to okay. I talk about science communication and I talk about the latest and greatest in science. If I'm going to champion science, LMAO, okay. So I'm not here to talk about philosophy. So I'm here mostly to talk about what's going on in science and to help people understand the basics. If you want to talk about philosophy, that's somewhere else. The last two variables are known. The rest, however, suggest a really large number. If you wanted those last two, 1/1000 or less, we are talking less than 1 CIV per galaxy. Okay. Fair enough. All right. So, what are the challenges that are facing with the Mars mission? Plus, the radio waves we first transmitted would be very dispersed. That's true. That's true. So, I mean, there's lots of different things to consider. It's just, we wouldn't have any signals reaching that particular galaxy yet. So, we wouldn't have any signals that particular galaxy would have gotten just yet from us because it's billions and billions of years ago. Oh, Andy's throwing variables at us. R times FP times NE times FL times FI times FC times L. Yes. So if you're not familiar with the Drake equation, I actually go on Paulogia's channel. If you're not familiar with Paulogia, oh goodness. P. Mars. I think she lacks an understanding of how those in power will use science to control and manipulate people. Now, I'm pretty certain I think anybody where you have humans involved in any kind of situation, that's pretty much everywhere all the time. And so I don't focus on that because I'm not interested in that so much. And again, that's philosophy. That's not science. That's not what I talk about here. And I have talked readily about how people manipulate and use others. You should check out my Science of Influence, P. Mars. You might find that pretty interesting if you want to know how people use stuff and to manipulate and use others. And I even talk a little bit about trolls and narcissists and that sort of thing. So I do touch on psychology a little bit. That's a bit more psychology than it is other things, psychology and philosophy. All right. This topic is about life outside of Earth, not how people use power to manipulate others, although I have discussed that in another episode. Check that out, PMARS. All right, so Paulogia. Go check out his channel. I hop over there and talk about the possibility of life on his show as well, and he animates me as well. So I've been on his show talking about, and I discussed the Drake equation there. So I'll shoot you over there if you're going to check out something. You can go find me on Paulogia's channel talking about life outside of Earth, and I discuss a bit about Titan and a little bit about those formation of molecules. That's pretty cool. Yes, I love Carl Sagan. He does talk about the Drake equation as well. Yes, science and philosophy are connected, yes, but not so much, and I don't really talk a whole lot about that on this channel. I mostly talk about hard concepts and break it down into more manageable, bite-sized bits so people can enjoy that. That's what I do. And sometimes I do talk about societal issues because some things affect me, so I do bring that all that. Why is moonlight cooler than moonshade? Science is natural philosophy that actually works. Oh my goodness. Well, let me touch on a bit because I'm almost at a flat hour, guys. You guys are so awesome and you make this so much fun for me. The biggest obstacle for the Mars mission, as we go back to that, is preparing humans and preparing for humans to survive the harsh conditions of Mars. Now, robotic spacecraft is the first step in understanding fully the conditions of Mars, what to expect for human sustainability. Now, NASA is hopeful that we will have a place on Mars in the next 11 years, but that's going to take demo runs. That's going to take going and sending robots down to the surface as well as collecting more information on where the best place would be for that. So, hello, Deathpool Wilson. So, that's the biggest obstacles we have to overcome for the Mars mission. And also, they're getting better about, one issue was the bone and tissue and muscle degeneration that's associated with zero gravity types of conditions and microgravity conditions, because we have to have gravity in order to maintain bone density as well as muscle density. And so the ISS and the twin studies that NASA did involving the two twins both in space, the year in space and the year on Earth, and comparing the two and to see which particular genes are shut off and turned back on. That is extremely valuable information for NASA to understand the effects of microgravity on the human body, which also helps NASA prepare humans for space travel over that period of several months that it would take to get to Mars. So, so that's kind of what we're looking at. Recently, we found the dark side of the moon. No xenomorphs yet. You know, that's the one thing that I try really hard to enjoy sci-fi. I really, really do. And I try to suspend disbelief as much as possible. But sometimes, like the Prometheus film, I'm like, golly, what in the world? Oh, goodness. I should have a better understanding of how people manipulate and use power in order to influence others. Yeah, that makes me better with being a science communicator, I guess. So, oh, goodness. Would help in preventing some of those issues. Yeah, maybe. But yeah, I don't know. I try to suspend disbelief when I'm watching science fiction and stuff, but sometimes it's just so hard to do because it's hard for me to turn off my science. So last weekend, I went and saw Aquaman. And all it did was generate so many questions for me. And so I kind of went through and live tweeted my Aquaman experience without spoilers, guys. Without spoilers. So from time to time, if you're on my Twitter, it's kind of a weird ride that I go through sometimes. And I go like, okay, so I have a really interesting question. They had a diversification of Atlantean species. How exactly did that happen? What kind of thing is going over here? So, oh my goodness. So it's just, I tend, that was pretty funny. Sometimes these things, I like that because it generates more questions for me. And you know, and if other people thought that way, they'd be like, oh, wow. You know, and I kind of like generating that imaginative spark. It's like, oh, what would be the possibilities? How could Aquaman persist? How could this be real? How could people live underwater? How could they could do this? Why is their armor not cause them to sink? They must be super strong. But how is it that Aquaman can live on there? And then, you know, Mera could come up on land, but the other Atlanteans can't. I have so many questions. So that's kind of what I do through all that. So let me catch up on your questions here. Why is it that when viewing the moon from near the Earth North Pole and then viewing them so that the constellations behind it are the same? They should be. I'm not certain what you're asking, Mr. Richington or Miss Richington. What do you think of P.F. Hugh Ross and his hypothesis that there's pristine early Earth fossils on the moon? I don't, okay, so I haven't read on that, so I can't comment heavily on that, but I don't know that there'd be pristine early Earth fossils. I wouldn't know about that. I know about the birth of the moon. So it would be interesting maybe to explore a bit more, like subsurface level might be interesting. We might have to go the biofroming route if we want to do long-range space travel. Yeah. I'd have to agree with that. An interesting fun fact, some of Earth bacteria will accept XNAs, but they have yet to figure out how to synthesize them. If they are at... Oh, thank you, Nether, for answering that question to Richington. The Ancient Alien show makes Earth seem like a roadside attraction on Space Route 66. Oh, my goodness. So, we're at a flat hour. I started late, guys. I started 15 minutes late. I spent a few, actually, I started working on this show. I got up this morning at 7:30. I slept a little bit later than usual. And as soon as I wake up, I start working on the show as quickly as possible. So I don't, you know, I do spend a lot of time on the show, especially when I know what the topic is. Used to, I wouldn't know what my topic is until like Thursday. So we're doing better about getting our polls sooner. Now, next Saturday morning, guys, I'm going to try to live stream because I will be in NOLA. I'm going to go to the Pharmacist Museum. So for Spirited Science, I will be there with Monty from the Monty and Hannibal, or Hannibal and Monty show. I do a weekly spot for them every week, so if you haven't checked them out, Hannibal and Monty's show. They're recently on the Geek Room. They were on, I think it was Three Black Atheists, and they were on the Peasants show. So they're on there a lot, and they're very, very funny. I've known Monty for about 8 years. I think it's 8 years now. And he did my original logo. Right over there, he did my original logo for me for this show. So on Spirited Science will air, I believe it's, I think we're slated for 6 p.m. Central Standard Time next Saturday. I'll be with Andy from Sunday Science from Sci Strikes channel. I will be with Monty from Hannibal Monty's show. I will be there, and we have a drink called the Pharmacist that we've made, and I will post a trailer for that soon. That will be Saturday night. Now, Saturday morning, 10 a.m. Central Standard Time, next Saturday, I'm going to try to live stream from the Pharmacy Museum in New Orleans, where the first licensed pharmacist was, and there's some folklore surrounded around that from he had sold the building to another doctor, Dr. Dupas, who apparently, there's no evidence for this right now, but they like to say that he used to experiment on African slaves, women who were pregnant. So we'll talk a little bit about eugenics and its practice in Louisiana on Saturday night for Spirited Science. But I would like to live stream. So next Saturday, we'll do the Science of the Pharmacy Museum live streaming from New Orleans. And then that evening, Spirited Science. So that would be awesome. Hello, Nana, N-A-N-A, my most recent patron on patreon.com. So that's pretty exciting. So what have we talked about today? And movie night on SciStrike's channel is moved from last night to tonight. Woohoo! Do check that out. Alright, so I'm going to go back over a little bit what we talked about. We talked about life in space. What is astrobiology? Where could we find life? What kind? Probably single cellular, but maybe multicellular organisms like tardigrades. What needs to be there for life? Well, we'd have to have essentially probably some sort of energy. It has to be able to burn energy, reproduce, this sort of thing. We would probably likely find some kind of organic molecules associated with life, being like, carbon-based stuff. So is Mars mission really possible? Yes. NASA has a timeline, mars-1.com. Go check it out, and you can see the timeline that they've got going on for that. So I'm going to take a moment to thank all of my amazing patrons. You guys, I don't think you realize how important my patrons are to me. I try to do as much as I can. They get exclusive artwork on patreon.com. They also get behind the scenes stuff. I'll do little short videos and post them on there about things that I'm doing. My patrons are essential to me to help me keep the lights on. Because of them, I've got a new camera. Yay! I'm going to be able to make like short films again. I actually used to make lots of short films when I lived in Vegas. So I got a new camera. I have new lights. They help me stream to multi-platforms because that stuff costs money. I have my website, ScientistMel.com, because of my patrons. So thank you, James, Jen, Carl, Melanie, Patrick, Daniel, Stephen. Oh, goodness. I have so many. They're wonderful. Paula, Carrie, Cersei, Keith, Duke, James, Nana, yay, thank you for joining me. Andy, who's here in the chat. Zachary, Tony, Bo, Steven, Sarah, Chris, Graham, Dragnot, Codless Iowan, Jennifer, Richard, Doc, Fearsome, and Neil. Thank you for being one of my patrons and helping me keep the lights on and doing everything that I can. So I can't thank you enough. I have better equipment. I have better technology. I have lots of different things that I can do now. I also pay for advertising to help boost science literacy on various platforms, which helps as well. So thank you. My goal is to reach enough patrons at some point in time to where I could just make this my job, travel throughout the U.S., engage with not only local communities but teachers, but also help people understand science through adult outreach programs, as well as eventually get to building a science communicator type of convention where we could have it like Comic-Con except for science, which would be awesome. Yes, and I do go after frauds. I bust up bad science. I have a new show coming up with Katie Paulson called This Week in BS, and we're currently writing it right now, and that's scheduled to air in 12 days. I believe that's January 24th. We'll have our first episode of This Week in BS. So it's awesome. I can't wait. This is where you can find me. Everywhere on the internet. ScientistMel.com, Patreon, Periscope, YouTube, Facebook. I'm also on Twitch. Please do like, share, and subscribe if you like what I do. I organize my shows according to playlists. And soon I'm going to organize playlists associated with content. Biology, I'll have a playlist for just biology topics. I'll have a playlist for physics. I'll have a playlist for space. I'll have a playlist for chemistry. So you can go and check it out. Quantum entanglement, yes. If you want, you can always shoot me ideas. All of my shows are topics from viewers. My viewers pick what it is that I do and what I talk about, and then I post polls. I can now post polls on YouTube. So I'll be posting polls on YouTube as well as Twitter. You can always, toss out ideas, and then I make a list. I actually have a little notepad right here where I write everybody's stuff down, and then I pop it in on a poll, and the topic that wins goes into. Yes, Annie wants me to start a statistical physics class. Yes, we have to start that soon, and so maybe I can throw that stuff in there as well. So that would be a lot of fun. So you can contact me through my website, Twitter. You can leave me a message here on YouTube, and you can also email me through my website. So you guys are so awesome. You guys have been watching my stuff so much. I'm now being consideration for is under review for monetizations for YouTube. Yay! Metamaterials. All right, I've got metamaterials and I've got quantum entanglement. Last weekend I talked about spectroscopy and all the different ways we can measure the things in solutions and find out how and talk about how spectroscopy works. So that was one of the topics. So I will be posting a new poll for not this Saturday, but the following, because this Saturday we'll be on site with a pharmacy museum. I don't normally get political, but I do bust up bad science when I see it because that's extremely important. And so, especially if there's harmful rhetoric coming from licensed care professionals, like a certain one that I ended up kind of getting about on Twitter, pushing harmful rhetoric that's actually quite problematic. So, Nova just did a show on it. Ooh, metamaterials. That's cool. All right, well, thank you guys for stopping by. And so I'll just kind of wrap it up here. But do check me out next Saturday morning and Saturday evening on the science of the First Pharmacy Museum. And you can check out Spirited Science making a return soon on this channel. Yay! So this has been the science of life outside of Earth. Thank you guys so much for being here. I'm still working on my YouTube channel, cleaning it up, and Nacha has offered to help me a little bit with my thumbnails. But if you want to help me out too, just shoot me up a DM on Twitter or message me here or any of those ways. I always, always, always accept and rely on the kindness of others. And so I'll end it with Mr. Rogers. I love Mr. Rogers. You always make each day special for me. You know how? By just your being you. Continue to be awesome, and I'm sending squishy science hugs. Bye. Thank you for being here.